All right. Let's look at section 3 now. We finished section 2 and section 1 and did the library functions. Yes, we are moving slow, but don't worry, I'd much rather move slow and make everybody understand the basics, and then we can pick up and move much faster. So what is a linear function? From what we talked about last time, what can you tell me? What does it look like? What can you tell me about it?
Are you referring to the
No, because domain range could be the same with other functions.
Right.
Yeah, you can say that it's a straight line. Even though if you think about it, that's redundant. A line by definition is straight. A straight line is a straight line. But no, but how do we know if we look at it, if a function is linear? Last time we talked about the library of functions. From our library of functions, which equations turn out to be linear? No, because so is the absolute value, or so is the cube root of the number, or the cube function. When we think of a straight line, we think of this. Or we think of this. Or from our library of functions, we think of that. We think of this. And lastly, we think of this. So when we talk about linear function, these are the only ways they can look. What do you notice about these graphs? They don't have any curves. They don't have any asymptotes. They don't have any holes. They pretty much go in a straight line. If you have something like this is the line is positive. Why do we know it's positive? Because as x, we always remember the horizontal axis is our time. It's always a. As x gets bigger, what happens to the graph? It increases. It goes up. So as x goes to the right, y goes, that means it's positive. So what does this one mean? This is a negative line. Take off your hoods. Why do we know it's negative? Yes, as x is increasing, y is going down. What is these next two we talked about last week? This is your identity function. Y equals x, or f of x equals x. A diagonal line. What about this one? Y equals some, this is a constant function. F of x equals some constant function. Yeah, whatever the constant is, bless you, that's where you cross the y-axis. You notice, okay, with this one here, you have y equals x. If your function has an x variable, it's going to cross the x-axis. If your variable has a y variable, if your function has a y variable, it's going to cross the y-axis. How about this one? Like y equals 3. What do we know about that equation? It's going to cross the y at 3. Will it cross the x-axis? No. Because there's no x, it can't cross, so it has to be a horizontal line. In this next couple of sections, we're going to talk about these two. When we talk about equations of lines, this is the first thing that pops into our head, our formula for a slope, or for a line. In this case, y is positive, so let's say something like 3x plus, let's say 2. This one, since it's a negative equation, it's going down, the slope is negative. Remember, in the first section, how do we define slope? What formula do we use for slope? But what does it equal? What does it equal? Remember I said in mathematics, you have to have a variable. What does it equal? Look at back your notes. What does the slope equation equal? M. M is your slope. So that's what that defines. Your slope is M. You have to know what these things mean. Because if I give you a formula, well, there's an M. We know what that means. That means a slope. Yeah, you have to memorize all these things. Those are the type of quizzes I'm going to start having also, of definitions of symbols and things like that. You have to know what these things mean. So if your slope is positive, it looks like this. If your slope is negative, it goes down. If there's no slope, it's horizontal. Look, what do you think this equation looks like? What do you think this equation looks like? We know this one, it's a horizontal line. So it crosses through 3. So it looks like this. So what do you think this is going to look like? X equals 3. Because as you said, there's no y-intercept, so it can't have a y value. If it doesn't have a y value, it has to have an x. It has to have one or the other. Are all of these functions? Let me ask you again. What defines a function? If you could do what? A vertical line, and what happens? Only once. Only once. Right. That's called a what? Very good. Vertical line test. If you could draw a vertical line, it only touches the graph once. Let me ask you again. Vertical line only touches the graph once. Is this a function? Let me ask you again. This is the graph of the function, right? If I draw a vertical line, how many times does it touch that graph? Every point is a vertical line. So this is not a function. It's not a function because it fails the vertical line test at every point. So what we're going to look at here are linear functions will have this shape. When we talk about functions, M and B are constant. For example, the example I had earlier, 2x plus 3, once I define my M and my B, this is my function. Now, if you notice the x, there's nothing on it, in front of it, behind it, under, there's no square root, no square, no power. That's a linear function when it's just x by itself. And it's not on the bottom under a division sign. There's nothing around it. That's a linear function. Because it's a linear function, the graph's going to look like what? You can't use straight and word line the same one. The linear function will have what? A line as a graph. Look at the first four letters of linear. Line. How many points do you need to draw a line? 2. So all you have to do is pick an x value, plug it in there, and then that'll give you the y value. This is the x and this is the y. So if x is 0, what's y? 3. X is 2, what's y? Yeah, those are my 2 points. I plot those points, connect the dots, and I'm done. So far, so good. What's the slope of my line? How do you know? Yeah, the slope is whatever's in front of the x. The slope is whatever is in front of the x. What's my slope and what's my b? Kind of, sort of, yes. Your b is 2, but what does b stand for? What does it stand for? Very good. It's the y-intercept. A y-intercept is a point. It's a location. So 2 is not right. It's at 0, 2. Yes, the value of b is 2, but the b, what it represents is at 0, 2. So far, so good. Now, if I asked you to graph this one, how would you do it? What kind of graph is it going to give you? It's going to be linear because the y has no powers or anything. So to draw a graph, what do you need of a line? We just talked about it a second ago. 2 points. Once you find 2 points, then you have the graph. But there's another way. To graph a linear equation, y equals mx plus b. First step, solve for y. You have to have the y by itself. It has to be y equals mx plus b. we're going to be using this example up here. Check. Y is by itself. Step 2. Plot B. Plot your y-intercept. So in this equation, my y-intercept is 2. I put a dot at 0, 2. Step 3, from your B, follow the slope to the next point. Remember, your slope is always a fraction. A over B. It's always a fraction. So in our example, what's our slope? What's M? M is equal to, you said, -1. How would you make that a fraction? Every number is a fraction. Every number is a rational number. 3 is the same thing as 3 divided by 1. So what does this tell me in my slope? So from this point, it's negative, so I go down 1, then over 1, and connect the dots. There's my graph. That's all you have to do. Graph that equation. What's the first thing you have to do? So what do you get rid of first? Subtract 12x from both sides. So we have 4y -12x plus 4. Then divide by 4. So we got y is equal to -3x plus 1. 4 goes into 4 once, 4 goes into 12 3 times. So it's, the slope is actually -3 over 1. So how do we graph this? What's the first thing I plot? With the y-intercept, which is at
0,
0, 1. Then my slope says do what? Yeah, from this point, go 1, 2, 3 down, and then over 1. Connect the dots, and there's my graph. Pretty easy. Ooh, here's another example. There. Let's make it 8. Make it bigger. First step,
Line.
to move the 2x. So here's the y. So move everything that's not. So I subtract 2x from both sides. Those cancel. So we have 8. Now, remember, I'm trying to save you all a chance of making errors. Whenever you're in this position, how many of y'all divided by -4? Good. What you always want to do, since you have a negative here, first off, change the signs. First off, change the signs. Treat the signs and numbers separately. Because if you divide by -4, there's too many signs, horizontal lines, signs everywhere. You can get them mixed up. This way, if you change the signs, nothing to worry about. Then I divide by 4. 8 divided by 4 is 2, so the answer is -2. What does this graph look like? Very good. Crossing through where? Right. It's a horizontal line at -2. Because there's no x. Let's put some of these things together now. So we know if it's just the y value, it's a horizontal line, right? What's the slope of that line? Y0.
Not moving up or down.
Very good. Remember, the equation looks like this. That's the equation of a line. How do because x and y have to stay there. How do I get rid of this number? What does m have to be to get rid of it?
2.
Yeah, if m equals 0, then that disappears. Then we have y equals b. So whenever you see a horizontal line, you know the slope is equal to 0. Whenever you have a horizontal line, the slope is equal. And conversely, if I tell you the slope is 0, then you know it's what kind of graph? Horizontal line. So you have to understand how those two are connected. Likewise, if we had a vertical line, what's that equation going to look like? X equals wherever it crosses. There's no y, so it doesn't move anywhere. What's my slope here? Well, it's both. Yes, it's undefined infinity. Why is it undefined?
Stacking on top of each other.
Well, you're both correct, actually. Let's look at these 2 points. What's the location of this point?
No, 3, 1.
What's the location of this point? So if it's a vertical line, remember the formula for the slope is y2 minus y1, x2 minus x1. So this is x1, y1, this is x2, y2. So what's y2? Y2 is the top one. Y1 is 1. X2, X1. So we have 2 minus 1, 3 minus 3. Whenever you divide by 0, it's undefined, which means it's infinity. It's both. You guys are both right. So whenever you have an undefined slope, you know it's a vertical line. So if your slope is undefined, then your equation is simply going to be x equals wherever it crosses the x-axis. It's a vertical line. If your slope equals 0, the equation is simply where it crosses the y-axis, and this is a horizontal line. Let's go further. What does this mean? This means all y values are the same. All y values are the same. If all the y values are the same, then it's y equals whatever that is, because it's on top. If it's this one, all x values are the same, because the bottom has to be 0. So, as simple as these sound, the better you understand this connection between them, the easier this part's going to be. If I give you a bunch of points, if I give you 2 points, what do we know about that graph? It's horizontal because the y values are the same. So what's the equation of the graph? What's the slope? Because you're going to be asked to find equations of lines given 2 points. If I give you 2 points that have the same y values, you're done. You don't have to do anything else. Or if I give you -2, 1, -2, -2, what can you tell me about that? Yeah, since the x values are the same, it's a vertical line. What's the equation going to look like? Here's the equation of the line. Since the x values are the same, x equals -2. Since the x values are the same, that means the bottom goes to 0. That means the slope is undefined. So those are shortcuts for you, because you're going to see this in homework or tests. It looks easy when I do it, but when you're by yourself, you're going to see this. And I guarantee what's going to happen is if I give you 2 points, first thing you're going to do, you're going to plug it in this and you're going to see what happens. Or then you're going to plot these 2 points and you're going to see what happens. So even if you plot them, even if you plot these two, you'll see it's a horizontal line for this first one. And at -2, it's a vertical line because all the points are going to be on the same vertical line. I'm trying to save you time. Here is a simple question. Example 1. Graph the function -2/3 x plus 1 and determine the slope. Excuse me. So if I was to graph this, how would I graph it?
Plot B,
Which is on which axis?
the Y.
Yep, so 1 on the y-axis, I put a dot. From there, I do what? Which is do what?
Go down to.
Yeah. Go
Right.
down 2, and the bottom. If you ever have a slope that looks like this, the negative always goes with the top number. The bottom number always goes to the right. So we go down 2, 1, 2, and over 3, 1, 2, 3. And connect the dots. And there's your graph. So what's my slope? The slope is whatever's in front of the x. Okay, graph these two. All right. The first one, what's the graph going to look like? Going through. It's a vertical line going through -2. What's the slope? Undefined, but it's vertical. And the second one? It's a what kind of graph? It's a horizontal line crossing y at 1/2. And what's the slope there? 0. Very good. Here's an example 3. Americans with Disabilities Act mandate that for wheelchairs, for every 1 foot of vertical distance, there has to be at least 12 feet of length. So for every 1 foot of vertical distance, there has to be 12 foot of. What if hours at our school Is that in compliance? If this is the ADA, American Disabilities Act, says for every 1 foot up, it has to be 12 feet out. Is our school in compliance? Yes, it is. Because if it has to be at least 12, it can be bigger. So yes, it's compliant. So what is the grade of our ramp? What is the grade of our ramp? You ever hear that? The word grade?
No, I think it's
No. Grade is the same thing as what? Slope. You can't grade a ramp. It's 100. No, you can't grade that. When you hear grade, that talks about the slope. If you ever go out to the Texas Motor Speedway on the turns are going to look something like this. Why is it so steep? Well, because the cars are going over 200 miles an hour. What force is acting on the car when it's going around the turns? It wants them to go out. If it was level, they'd never make it. They slide off. So they have to make the ramps angled. Look at the highways when you drive them next time. Whenever you get to a turn, whether it's a bridge or anything, slow down and look at it. You without even knowing it, your car is going to be doing this because the road itself is slanted. Every turn on the highway, every exit, every bridge that has a turn has to have a slope, a grade of this. So if they have 24 feet width of highway space, it's got to be at least 2 feet. So it's got to be from this side. If it's 24 feet, then it's got to be 2 feet up. That's what your ramps are going to look like. You never noticed that, have you? No, because it's made to feel when you're in your car at that speed, you don't feel it because your car will be always pointing straight down on it. What happens if you go too fast on that curve? You slide off and hit it. That's where you see all those scuff marks on the side of the ramps. People didn't make it. So what's the grade of this? Or what's the slope of this ramp? What's the formula for slope? Yeah. Change of y over change of x. So what is the change of y in this one? 1 over 14. So 1 over 14. And you do that, multiply by 100, you get a percent. And this one's going to give us 7.1% grade. Part over total times 100 is a percent. So this will give you a 7.1% grade. And that's the minimum you need. So whenever you hear the word grade, it means slope in engineering. Another use of slope in business or in physics is the average rate of change. This is the same thing as the slope. So here's our example. The number of people participating in the Federal Supplemental Nutrition Assistance Program, food stamps, has increased from 17.2 million in 2000 to 47.6 million in 2013. Following the graph, find the average rate of change from the people from 2001 to 2013. So find the average rate of change. Why is it called the average rate of change? How do you find the average of something? If you had two test scores, you made an 80 and a 95. How would you find the average of those two test scores?
I don't know, because I don't.
Which is what we're doing here. The average rate of change is your slope, because you have the amount of distance between the two on vertically over the amount between there. So we have it from 2000, we had 17.2. And then at 2013, we had 47.6. So we're just looking at the average rate of change of these two, the slope between those two. So what's Y2?
47.
Yeah, it's 47.6 minus 17.2. This is Y2. This is Y1. This is X2, and this is X1. So this is 30.4 over 13. So 226, 26 to 4, 2.3, 2.28, 2.3. So that's your slope. Pretty easy. Let's look at oil imports. Increased oil production in the United States has resulted in a decreased imports of crude oil. The total number of barrels imported in 2008 was 3,590,000. The number decreased to 2,810,000 barrels in 2013. Find the average rate of change of crude oil imports. This is example 5. So it went in 2008, it was 3,590,000. In 2013, it was 2,810,000 barrels. So we're looking for the slope, which is Y2, Y1, X2 minus X1. Because X is always time. X is always time. That means the first one has to be X1, the second one has to be X2. And then so the corresponding Y values are those. 2,810,000 minus 3,590,000. 2013 minus 2008. Because 3 million is higher than 2 million, answer is going to be negative. Subtract these. It makes it 780,000 over 5. Goes in 5 goes in 7 once with 2 left over. 5 goes in 28 5 times with 3 left over. 5 goes into 36 times. So my slope is that. So how would you interpret this? What does this mean to you? If you saw this in this example, what does that tell you? It seems, but what, how would you put this in a sentence? But that doesn't have anything to do with what we talked about.
What was the question? So the decrease by them like per year.
By year, yes. So oil production decreased at a rate of negative 156,000 per year. You always have to answer the question that it's asking you. Yeah, I put it up there pretty quick. We're good. So the equation that we started off with, we normally call this the equation of a line, but it's got another name, a more technical name. What does M stand for? What does B stand for? So the name of this is the slope intercept equation, or form, or anything, anyhow you want to say it. It's a force slope intercept form, slope intercept equation, doesn't matter. Let's see an example. Example 7. Find M and B of 3x minus 6y minus 7 equals 0. You need another pencil? I got some here. I got some for you. I give you one of these mechanical ones.
Yeah, I got one. I don't like the mechanical.
Oh, yeah, okay. So the first thing you have to do is what? Yeah, the first thing you have to put it in this form. So we have to subtract 3x. Actually, even easier. What would you move first? Actually, think about it. You want to have y to be positive, right? It's negative right now. What if we move this to the other side? If we added 6y to both sides, then we have positive 6y equals 3x minus 7. What you always talking about, it was not wrong, but this is saving you some time. If your y is ever negative in the first step, move that one. Then you do what? Divide every term by 6. So this is 1 over 2, which is the same thing as x over 2 minus 7/6. So what's your slope? And what's your y-intercept? Yeah, remember the slope cannot have X. So it's the numbers 1/2. And the y-intercept? So the B is what? Nope, -7/6. Or 0, -7/6. It all depends on how the question is asking it. Because this is your y-intercept. Let's move on. All right, that's it for that section.